All right, so we know what a perfect square is. Perfect square is a number whose square root is whole. We filled in all of our squares. New stuff for today. So, remind me, when adding and subtracting terms, you must have like terms. In order to combine them. For example, can I combine 2x and 4x? And it gives you 6x. Everybody good? Can you combine 2x and 4y? No, because they are not like terms. Okay. When multiplying and dividing terms, you blank in order to combine them. You don't need like terms. In order to combine them. Don't have to have like terms if I'm multiplying. So, am I allowed to multiply 2x and 4y? Yes, what does that give you? 8xy. You multiply the coefficients and you multiply the variables, right? Okay. The same is true for radicals. Everybody see this big old cap statement right here? The same is true for radicals. So, if you look at your paper today and you look at the top of your paper, it says we're going to be multiplying radicals, correct? Okay, so when multiplying and dividing radicals, you do not need to have like radicals. You do not need to have like radicals. You will multiply the coefficients and you will multiply the radicals. When you're done with all that, you need to go back to what we've been doing the past couple days. Then you need to simplify it. How we were breaking it down the past couple days? Is that all right for everybody? Okay. So you ready? All right, let's see down there. Are we multiplying? Yeah. Yes. If we're multiplying, we do not have to have the same radicals. So I need to multiply coefficients, and then I need to multiply radicals. So if I multiply the coefficients, what do I get? 12. If you multiply what's under the radicals, what do you get? 36. How's everybody doing? Now I need to simplify if I can. Good news is 36 is a perfect square. What is the square root of 36? So it's really 12 times 6. Notice there's no more radical there because that was a perfect square. What do you get? 72 will be my final answer. Okay. Number 2. Got any coefficients to multiply? No. It could be 1. You don't have to put the 1. Before I get to multiplying my radicals, what do you notice? There is nothing outside. What do you notice, though? They're not perfect squares? Yeah, what is the square root of 4? 2. So this is really 2 times the square root of 7, right? Well, what is 2 times the square root of 7? No. This one is outside the radical. That one's underneath, isn't it? No. Yeah, I want exact, which means I don't want a bit. But is that all the numbers in your? No. It's just 2 radical 7. Think of it this way, folks. If I told you 5 times x, what would you tell me? It'd be 5x, right? So if I tell you 2 times radical 7, you're going to tell me 2 radical 7. Now, what if you didn't notice that 4 was a perfect square? You would have multiplied the radicals together, right? So would you have gotten radical 28? Because 4 times 7 is 28? And then we would need to break it down. What does 28 break into? What does 4 break into? So it'd look like this, right? Do I have any pairs? And only one of them comes out, right? What's left underneath? Same thing. Way quicker to just do it the first way, though, right? Okay. Number 3, do you have any coefficients to multiply? Yep, which gives you? How about under the radical? Yep. Okay, is 63 perfect? It is not, so let's break it down. What can we break 63 into? Yeah, we just multiplied 3 and 21, right? The 3's done. How about the 21? Looking good? Okay. I already have a 40 out front. Do I have any buddies? I got a pair of 3s. So one of those 3s comes out. What's left underneath? Okay. And then 40 times 3, 120, radical 7. Okay. Number 4, do you have any coefficients to multiply? Which gives you? How about under the radical? Which makes 4, but we know 4 is perfect square. What is the square root of 4? So this is really 35 times 2, which is 70. Good. How we doing on the front there, okay? No problems? Maybe Monday. We'll use the whiteboards again. All right, number 5. Look at it carefully before we start. I see the negative 6. What's that? There's only one coefficient, right? The negative 6. What else do you notice? 64 is perfect, isn't it? What is 64? 8. So really, we have this now, don't we? Okay. Well, is 8 under the radical or outside the radical? This 8? It was a perfect square, right? So the radical's gone. It's outside, so that means it gets multiplied by the other thing that's outside. What does that? Oh no, what does this give you? And we still have the radical 45 though, right, folks? Is 45 perfect by chance? No, so we've got to break it down. What are you going to break 45 into? Say it again. I think you were right, I just didn't hear you. 9 and 5? You could do 15 and 3. What does 9 break into? Okay, so we already had the negative 48 out there. I got any pairs? So one of those 3's comes out. What's left underneath? 5. Okay. What is negative 48 times 3? Radical 5. Now, bless you. Now, could you have just multiplied the 45 and the 64 together? Yes, but it would have been a pretty large number for you to break down, right? Okay. Number 6. Any coefficients to multiply? Any perfect squares to deal with right off the bat? So now you have to multiply them together. What do you get? All right. Is that perfect by chance? Nope. So let's break it down. Now, folks, we just multiplied something together to get that, right? So you can do 42 and 7. And the 7's done. What does a 42 break into? 21 and 2, I hear. And how about the 21? All right. So do I have any pairs? I got a pair of 7's. One of them's going to come out. What's left underneath? What is 3 times 2? And that would be your answer. Doing okay? All right. Number 7's not a multiplication problem. I just didn't want you to forget how to just straight up simplify. Is 507 a perfect square? Okay, it is not. So let's break it down. How about 169? That number should ring a bell to you. Not 13 and 2, it's 13 times 13. Everybody doing okay? So we've got a pair of 13s that's going to come out with that 4 that was already out there. And we've got a 3 left underneath. 52, radical 3. Okay, back to multiplying. Any coefficients to multiply? What's under the radical then? 10. Is 10 a perfect square? Which, we got to break it down. It'll be 5 times 2. Can I go any further than 5 times 2? You cannot. Do I have any pairs that can come out? No, so nothing gets out, right? So there'll still be a 5 times 2 left underneath, which means it's just going to stay the way it is. Nothing can come out of there. Oh, it's not too bad. All right, number 9. Got any coefficients? We have a 4, and there would be a 1 in front of that 3, right? So I'm just going to keep that 4 as my coefficient. How about under the radical? 6? Is 6 perfect? It is not perfect. Let's break it down. 3 times 2? Nothing gets out, does it? It's going to stay the way it is. All right, any coefficients at number 10? No? Multiply them and you get, is 18 perfect? No? Break it down. Break down the 6. Anybody getting out? A 3. What's left underneath? 2. Good. All right, how about number 11? What do you get on the outside? Negative 5. What do you get underneath? Ding, ding, ding. I like that one, right? What's the square root of 36? So this is really negative 5 times 6, which is good. Now, folks, I need to stress to you that when you have a perfect square and you actually do the square root and you get 6, there's no more radical over it. It's gone. All right, number 12. Outside of the radical, underneath the radical, which is good because the square root of 49 is 7. Yep. What is 8 times 7? Good. Interesting. Yeah, there's just more of them, right? Okay, so are there any numbers on the outside to multiply? No. So now you're just going to multiply all of the numbers underneath. How many? 36. And that's underneath, right? And what is the square root of 36? Good. It is. It is perfect square. So if you notice that, what is the square root of 4? 2. So it would really look like this. Then what's 3 times 3? 9, right? And what's the square root of 9? 3, right? And what's 3 times 2? Neither way is more correct than the other. Okay, you can do it either way. How about number 14? Got any coefficients? No? How much? 484. So what does that mean? There's no radical. It's perfect square, isn't it? What's the square root of 484? Do it. If you would have checked it first, we could have saved ourselves the 10 seconds it took us. 22, right? We just didn't go up that high. No. We just didn't go up that high. The perfect squares that we go up to, I think the highest was 400, right? 22 is, or I'm sorry, 484 is 22 squared. Is that all right? Everybody doing okay? You guys look confused for right now. That's all right. If you get done and there's nothing left, then there's nothing left on the radical. You don't need one. Okay? Questions for me? No? All right. And there's your homework.